Okay, and let me say thank you again. Here is Mwalim Nick, and I'm here again to just continue from where we left in the previous lesson. So in the previous lesson, we were talking about a temporary chemical change, and we looked at the sum of the substances we can use to demonstrate a temporary chemical change, where we mentioned hydrated copper 2 sulfate and hydrated cobalt 2 chloride. And I remember I said what is key here, the key point is to know what is happening, to know the meaning of hydrated and the color, the original color of these substances, and the color change when we heat these substances. Now, allow me please again to continue from where I left. Now, we had written these equations. These equations are the one we are calling word equations. They are here. In an exam, kwa mtihani, if somebody happens to ask you to write the word equations are here. So you don't have to struggle. In my class, you don't have to struggle. Step by step. And I believe that we'll have easy time answering the exams. Now, let me ask you a question, a provoking question. If you look at these two substances, hydrated copper 2 sulfate and hydrated cobalt 2 chloride, then you look at the substances which are obtained, which we are able to obtain after heating. Then you ask yourself a question. Are we able to recover hydrated copper 2 sulfate from anhydrous copper 2 sulfate? Are we able to get back the original substance, which is hydrated copper 2 sulfate, after heating it? Remember, it has changed from hydrated to anhydrous. And also the color has changed from blue to white. Now my question is this: are we able to get back hydrated copper 2 sulfate, which is blue in color? Then the next question: are we able to get back hydrated cobalt 2 chloride, which is pink in color, after heating? The answer is very simple. The answer is yes. I want to take you back to our subheading here. Temporary chemical change. The word temporary in this case means that the change does not happen permanently. Right? The change does not happen forever. No, we can be able to get the original substance which we had initially in the beginning of experiment. Now, how can we be able to recover hydrated copper 2 sulfate from anhydrous copper 2 sulfate? Very simple. You don't have to stress yourself. Angalia hapa, I want to show you something. If you heat hydrated copper 2 sulfate, what happens? It loses water. It loses water. Let me use an arrow here. It loses water. This one here. Plus water at the end of this equation means that hydrated copper 2 sulfate lost water during heating. Right. Now, what should we do to obtain back hydrated copper 2 sulfate from anhydrous copper 2 sulfate? Very simple. Just take little amount of water, then add it to anhydrous copper 2 sulfate. Then you will be able to get hydrated copper 2 sulfate. Because anhydrous copper 2 sulfate is only lacking water. So when we happen to add water in it, it goes back to hydrated. Remember the word hydrated, we said it contains water in its particle, right? As well as hydrated cobalt 2 chloride. When we heat it, we form anhydrous cobalt 2 chloride. So it loses water. That's why at the end of this equation we have plus water. Now how do we obtain an hydrated cobalt 2 chloride from anhydrous cobalt 2 chloride? In a simple term, anhydrous means it lacks water. So how do we make it hydrated? We add some little amount of water in it. Then we get hydrated cobalt 2 chloride. Allow me to write equation or to use equations to demonstrate this. So equation number 1, we have anhydrous. Let me use a different pen. Anhydrous copper 2 sulfate. Then you add a little amount of water. What do you get? Hydrated copper 2 sulfate. As simple as this. You don't have to worry. So anhydrous, it is white in color. Then hydrated, it is blue in color. We have recovered the original substance. We have recovered hydrated copper 2 sulfate from anhydrous copper 2 sulfate. What about anhydrous copper 2 chloride? Can we be able to get hydrated cobalt 2 chloride? Yes. Look here. So 2 we have anhydrous cobalt 2 chloride plus water. It's water. What do you get? Hydrated cobalt 2 chloride. As simple as this. What is the color of anhydrous cobalt 2 chloride? It is blue in color. It is blue in color. What is the color of hydrated cobalt 2 chloride? It is pink in color. It is pink in color. Now we have been able to obtain or to recover the original substances which we had. The hydrated copper 2 sulfate from anhydrous copper 2 sulfate. Hydrated cobalt 2 chloride from anhydrous cobalt 2 chloride. We therefore say that this type of change is reversible. This type of change is reversible. Reversible means we can be able to get the original substance which we had before heating. So these two type of changes, or this type of change, a temporary chemical change, is reversible, right? Now let's have a look at other characteristics. Characteristics of temporary chemical change. So the first one, the change is reversible. Then number 2, is there formation of a new substance in this type of change? I want you to look at these two equations here. In the beginning, we have hydrated copper 2 sulfate, which is blue in color. Then at the end of heating, we have anhydrous copper 2 sulfate, which is white in color. So there's a difference between anhydrous copper 2 sulfate and hydrated copper 2 sulfate. Therefore, these are two different substances. Now, we therefore say there is a formation of new substance. Or there's a formation of new substances. So there's a formation of new substances. Of course, the formation, the first new substance, and water is another substance. There's formation of new substances. There is formation of new substances. Initially, we had hydrated copper 2 sulfate. After heating, we have anhydrous copper 2 sulfate, which is a different substance from hydrated. Then we also have water. We therefore say, in temporary chemical change, there is formation of new substances. Then we need also to ask ourselves, the mass of these two substances. Does the mass of these two substances changes after heating? I'm asking you a question. If you look at these two substances, hydrated copper 2 sulfate and hydrated cobalt 2 chloride, does the mass change after heating? The answer is yes. And I want to take you back to these two equations here to see why I'm saying that the answer is yes. Let me use the first equation for hydrated copper 2 sulfate. Now, I say that the word hydrated means copper 2 sulfate has water in it. And let me assume that the mass of water is 6 grams, right? In copper 2 sulfate, right? Now, when you heat hydrated copper 2 sulfate, it loses water of crystallization. And for our case here, water is having a mass of 6 grams. So hydrated copper 2 sulfate, it will lose water. Let me say 6 grams of water has been lost during heating. So if you weigh the mass of anhydrous copper 2 sulfate, then you compare it with hydrated copper 2 sulfate, the mass of anhydrous will be less than hydrated, to mean the mass of a substance has changed. This change in mass, there is change in this change in mass. There is change in mass. This change in mass of a substance. This change in mass of a substance. This change in mass of a substance. So the characteristics, we are going to talk about the last characteristics, but allow me to again take you through the characteristics of temporary chemical change. The change is reversible. Good. We can be able to recover the original substance. We can be able to recover hydrated copper 2 sulfate from anhydrous copper 2 sulfate when we add little amount of water, this one, as well as we can be able to recover hydrated cobalt 2 chloride from anhydrous cobalt 2 chloride. So the change is reversible. Remember, in the temporary physical change, we said that the change is easily reversible. To mean you only need to cool zinc oxide to get yellow zinc oxide to get back a white zinc oxide. But for this one, it's not easily reversible. So we say just reversible. The reason why we are saying that it's not easily reversible, you need to add a little amount of water in anhydrous for you to get hydrated. If you just cool anhydrous copper 2 sulfate, which is white, you will not be able to obtain hydrated copper 2 sulfate. So you have to add little amount of water. Then there's formation of new substances. Of course, this is very clear. Hydrated copper 2 sulfate forms new substances, anhydrous copper 2 sulfate and water. Then there is change in mass of a substance. The mass of substance changes after heating. Then the last one, heat. It is either evolved or absorbed. So the last one here, when you add little amount of water in either anhydrous copper 2 sulfate, you are likely to feel some sort of heat. Or when you use a thermometer, you see the rising, the readings of thermometer, telling you that there's some evolution of heat or absorption of heat in the environment, right? So we are done with the temporary chemical change. Maybe next time we'll talk about these changes, temporary chemical changes in real life, right? Thank you very much for your time. Please don't forget to subscribe. Don't forget to share to your friends, to your peers. Let them be encouraged that when it comes to integrated science, is an easy area, the easiest one compared to other disciplines or other subjects which you're doing. So feel encouraged. You're free to ask any question in comment section. Let me get there some more questions. And also, I believe that by soon we'll begin revisions as we prepare ourselves for KJSER. Remember, we are doing this in preparation for KJSER. So have a nice time and let the God bless you as you purpose to share and subscribe to my channel. Thank you.